Hey everyone, let's take a look at the first one in section 6.3. We're going to calculate the volume of the solid obtained by revolving the region under the graph of this linear function, just x plus 5, about the x-axis over the interval from 0 to 4. So it helps to always graph this region first, or sketch this region. Let's graph the function x plus 5. It's just a line of slope 1 passing through the y-axis at y equal 5. And we're integrating from 0 to 4. So I've shaded in this sort of trapezoidal region here. So we're going to take this region and we're going to reflect it, or rotate it rather, about the x-axis. So it's going to come out of the page, back into the page, and go around. And it's going to form a solid. I tried to draw that solid here roughly. Right, so here is the coming out of here is the x-axis here, and this is that region that I shaded in right here. I'll just shade it in here. And that region is going about and forming this shape right here. And what we're computing is the volume, the capacity inside this object. It's kind of like, I'm not sure if put it this way, it looks like a lampshade, but again, we're finding the volume, the inside, what we can, or maybe this is like a little platform that you put on the ground and you stand on. I don't know. Any rate, there is the solid. The important thing is again, we're going to look at, uh, integrating with respect to x here from 0 to 4. And, again, we're breaking up the interval from 0 to 4 into n equally spaced subintervals to start with. And on one subinterval, I've got this rectangle here. I'm going to rotate that back around the x-axis. And what am I going to get? I'm going to get my disk. So this is the disk method here. And the area of this disk is just pi times its radius, capital R. And the radius here is just going to be the distance from the x-axis, right, to this curve right here, right? So this is the value of R, and it's just equal to, this is the graph of, again, the f of x, x minus 5, and this is, of course, the x-axis, which is y equals 0. And so that distance is just going to be x plus 5, right? When x is 0, that distance is 5. And when x is 4, that will be what? 4 plus 5, 9 would be the height there. But that's how it's varying over the interval from 0 to 4. So our area is pi times r squared, where r is x plus 5. And so we're just going to integrate that cross-sectional area, right, from x equals 0 to x equal 4. And that's what I've set up over here. So you could do this one real easy. I did a substitution here. Most of you already know the antiderivative of x plus 5 squared will be just 1/3 x plus 5 cubed, because the substitution, if I let u be x plus 5, the du is just dx. I went ahead and just changed the limits since I changed to u myself. X is 0, obviously. 0 plus 5 is 5, u is 5, x is 4, u is 9. And so this is what we're really integrating. And we get the antiderivative of u squared is 1/3 u cubed. Don't forget our pi here. Evaluate the upper u limit of 9 and the lower limit of 5 and subtract, and we get this value. Okay. So hopefully this makes sense. This, again, is the volume in cubic units for this shape here, this three-dimensional solid that we're getting by rotating this region about the x-axis. Hope this makes sense.